This call is now being recorded.
Good morning, students. Welcome to our subject Airport and Bridge Engineering. So, today we will see some of the multiple choice questions based on our syllabus. So, see the questions. These bold answers, bold choices are option or the answers. You can go through all the choices and remember the bold one as an answer.
MCQs, Unit 1 and Unit 2, Airport Engineering. 1. The main objective of a good airport layout is to reduce the length of runways, minimize aircraft taxiing distance, increase terminal building height, decrease passenger comfort. 2. Which of the following is a navigation and landing aid? ATC, ILS, hangars, aprons. 3. The term ATC stands for Airport Terminal Control, Air Traffic Control, Aeronautical Traffic Coordination, Aircraft Taxiway Communication. 4. ICAO stands for International Civil Aviation Organization, International Cargo Association Organization, International Civil Aerodrome Office, Indian Civil Aviation Office. 5. The geographic distribution of world air transport depends mainly on passenger needs only, economic activity and trade routes, climate only, political boundaries only. 6. Which configuration is used for parallel runways? Crosswind configuration, open V, closed V, parallel system. 7. Which is not part of an airport landside facility? Parking, passenger terminal, runway, ticket counters. 8. Zoning requirements at an airport primarily relate to limiting aircraft speed, regulating permissible building heights, fuel storage, passenger baggage handling. 9. A community with a population of about 50,000 generally requires which type of airport? International airport, regional airport, community airport, military base. 10. The runway orientation is decided mainly by passenger demand, wind direction, aircraft color, terminal building design. 11. Aprons at an airport are primarily used for aircraft parking and servicing, runway crossing, passenger entry, air traffic control. 12. Which of the following is not a function of terminal buildings? Passenger check-in, baggage handling, aircraft refueling, security checks. 13. A good airport site should have steep slopes, good drainage, high-rise buildings nearby, dense forests nearby. 14. Community size in airport classification relates to population served, airport type needed, number of airlines. None of the above. 15. Airports are classified functionally based on only passenger traffic, types of services offered, aircraft color, airport height. 16. Obstructions in the vicinity of an airport affect passenger comfort, aircraft safety during landing/takeoff, terminal design only. None. 17. ILS is used for passenger boarding, fueling aircraft, guiding aircraft during landing, apron maintenance. 18. The term air age refers to the lifespan of aircraft, the era of rapid air transport growth, airport construction period. None of the above. 19. Runway configuration depends on wind direction, aircraft types, Both A and B. None of these. 20. An airport's good layout must increase taxiing time, minimize aircraft movement distances, maximize number of runways regardless of need. None of these. 21. Which aircraft characteristic has the greatest influence on runway length? Engine type, wingspan, take-off weight, landing gear height. 22. Increasing aircraft size and speed leads to shorter runway requirements, higher turning radius requirements, less apron space, smaller taxiways. 23. Turning radius of an aircraft depends on engine thrust only, aircraft speed and wheelbase, fuel capacity, passenger capacity. 24. Which factor is not considered when selecting a site for an airport? Ground accessibility, wind conditions, political party in power, future expansion possibilities. 25. Runway width is governed by aircraft wingspan and wheel track, passenger demand, fuel availability, terminal size. 26. The main element of geometric design of an airport does not include runway, taxiway, control tower, apron. 27. Runway length is corrected for temperature and elevation, aircraft color, passenger luggage, weather forecast. 28. Which is the primary factor affecting runway orientation? Crosswinds, terminal location, ATC availability, fuel supply. 29. FAA stands for Federal Aviation Administration, Federation of Air Aerodromes, Flight Analysis Authority, Federal Aeronautics Agency. 30. Which of the following is part of analytical methods for air travel demand? Passenger survey, luggage weight, airport food court size, aircraft paint color. 31. The selection of an airport site requires consideration of topography, soil characteristics, meteorological conditions, all of the above. 32. Runway orientation study is carried out using soil report, windrows diagram, passenger survey, runway markings. 33. The minimum turning radius of an aircraft is influenced by nose gear steering angle, taxiway width, both A and B. None of these. 34. Runway profile refers to surface marking, longitudinal slope of runway, cross slope of taxiway. None. 35. A case study in airport master planning involves only passenger traffic, only cargo movement, comprehensive data on facilities, traffic, and growth. None. 36. Runway length calculation is influenced by airport elevation, ambient temperature, both A and B. None. 37. Taxiway width is decided based on passenger volume, wind speed, aircraft wheelbase and wingspan, runway length. 38. Apron size depends on number of runways, number and type of aircraft using it, terminal height, wind direction. 39. Geometric design of airports aims to increase congestion, reduce safety, ensure safe and efficient movement of aircraft, reduce runway length unnecessarily. 40. Master planning for airports is done for 1 year, 5 years, 20 years or more. No fixed period. 41. An airport designed for larger aircraft must have narrower taxiways, wider taxiways and longer runways, shorter runways, steeper slopes. 42. Site selection for an airport avoids plain terrain, good drainage, proximity to tall obstacles, Accessibility. 43 ICAO recommends runway strip width depending on aircraft age, aircraft wingspan category, airport revenue, passenger numbers. 44 airport capacity depends on runway configuration, taxiway system, apron capacity. All of these. 45 landside planning involves runway length, taxiway orientation, passenger terminal access and circulation, aircraft parking only. 46 airside planning includes parking lot design, runways, taxiways, aprons, security checkpoints, baggage claim. 47 runway markings are provided for decoration, guidance and safety. Painting practice. None. 48 future airport expansion is considered during runway resurfacing, initial master planning, apron cleaning, ATC shift change. 49 ILS primarily assists during takeoff, landing in poor visibility, taxiing, refueling.
Okay, so these are the some multiple choice questions based on the syllabus. If you have any doubt, please let us know. Or if you want to teach any particular topic in detail further as a revision. Okay, so who is going to present your topic? These multiple choice questions were just for practice, understanding the different concepts in depth. In day-to-day life also, you can see the applications of this subject in many ways. Airports play important role in the development of country. You can see in the present warfare situation also how airports are used, aircrafts are used, or various infrastructure facilities related to airports is becoming important for the warfare, logistic, and the support. Similarly, you can see the bridges are important to connect different parts of the country, or we can say valleys, rivers, to move infrastructural facilities, or even in the warfare situation, moving of the military or many other related uh, infrastructure facilities from one place or one corner of the country to the other corner of country. Similarly, you can see countries are targeting bridges of the other countries so that the infrastructure facilities will get paralyzed, or that particular country will not be in position to attack properly. So you can see what is important role of particularly airports and bridges in the safety of nation as well as during warfare situation. So if any one of you has not presented your topic, you can present it now, or I will continue the session. So you can see how a particular bridge is connecting these two places which are divided, or the obstacle is flowing river. So particular this alignment profile is designed as per the requirement. The type of bridge, this is cable stayed or suspension bridge. Can anyone tell? If this is cable stayed or suspension bridge. So this particular tendon is connected to the two pylons on the edge of the river, and the vertical strands are connected to this particular big tendon, which is in the form of sagging movement, we can say. And particularly this deck is supported by these vertical strands. So this is suspended. These strands are suspended from these larger tendons, or can say ropes. So this is suspension bridge, and particularly cable stayed bridge is little similar, but the pylon is, we can say, in between the water course, and suppose this particular pylon is here, and the cables are along this vertical part in a triangular fashion. So this will connect like this. One particular strand will be connecting here, another here, like this. So particular load transmission or transfer of load is different in uh, different type of bridges. So we have to select the type of bridge wisely depending upon the budget available, as well as we can say necessity of that particular area and the challenges. So site selection is based on all these requirements, some types of bridges. Then we have to provide openings to that particular bridges based on the discharge requirement. So we have to calculate the discharge which is to be flowing, or which will flow below the bridge, considering maximum flood level, accordingly waterway, number of spans, a flux, increase in height in the water level on the upstream side, score depth at the bottom of the foundation, then standard specifications for loads, forces, erection of superstructure, strengthening. So this one is arch bridge. So requirement of particular type of arch section will be justified by the profile, elevation, and the location. You can see this particular area, deep valley, and type of geological supports. A structure built to span and provide passage over a river, road, or any other physical hurdle. The function required from the bridge and the area where it is constructed decides the design of the bridge. So components of bridge, the main component of bridge are substructure, superstructure. So see this particular diagram for the bridge components. If hard strata is not available at lower depth, then we will go for pile foundation. Or if the hard strata is available at lower depth by open excavation, then you can do excavation also. So these are the parts of substructure, that is foundation. Then over the foundation or these piles, pile cap is there. So these piles are connected together, and from there you will see the pier is constructed. So this particular is pier or column which will be above the ground, and further it will be extended in form of pier cap so that it can take the connections or load transfer mechanism from the girders or as per the type of bridge, and which will support the deck. So these yellow part is, we can say, bearings. Above that is girder, and that is part of superstructure. So this is substructure, this is foundation, and this is superstructure. So the walls constructed, or sometimes the piers which are on the extreme edges, are part of abutment. There is wing wall which support the embankment wall or the sloping profile. The soil or the material is added so that particular this section will be open for the water discharge or to cover the valley, and this particular abutment or further to abutment will be on the uh, little upper land, and this is done so that economy will be achieved and the particularly span of the bridge will be less. Substructure components of the bridge below the level of bearings is known as substructure. It consists of the following. The function of the substructure is to support the superstructure components and transmit their load safely to the subsoil. Abutment, it is a structure mostly used for bridge and dam as a substructure at the ends of the bridge span or dam, and on that superstructure is rest. Bridge with single span has two abutments that offers vertical and lateral support. It also plays the role of retaining walls to resist lateral movement of earthen field of the bridge approach. So you can see this particular is abutment, wing wall. Here you can see little higher elevation, and this particular may be a river course in which the piers or columns will be constructed. So piers, this particular bridge is famous in the Uttar Pradesh. We have seen in the videos that one of the pier was getting washed away. So that was designed in form of shoe, considering the uh, hydraulics or the loads of or the forces acting on that particular pier. Streamline body, you must have heard. For that reason, the shape of that particular pier was changed. So pier provides intermediate support between two bridge spans. Piers provide intermediate support between the two bridge spans. So span is nothing but distance between two piers. So piers provide intermediate support between the two bridge spans. So these are the two bridge spans, and this particular pier supports these spans. So bridge piers mainly support the bridge superstructure element and transport the load to the foundation. Pier must be strong to handle the horizontal as well as lateral loads. We can say piers are known as compression members of the bridge. So on this particular pier, the vertical load is going to be acting in the downward direction. So that is compression. So you can see these steel plate girders are used as a deck or for the railways. So different types of bridges use different types of mechanisms to transfer the load as per the requirement, width, height. So even in the British era, they have constructed many bridges for the roads and railways, which are still used by us. And as development progresses, you can see that we are constructing now new bridges with the latest technology and uh, with huge spans or in the deeper valleys like Chenab River Bridge or we can say Pamban Bridge. So as technology progresses, we are expanding our infrastructure in the remote areas, in the undeveloped areas to have major infrastructure facilities, transportation for roads, railways, and many more infrastructure facilities. Wing walls. So this is the wing wall. We can say like a wing of a bird in C shape. It is one of the earth retaining structures in the bridge. They are located adjacent to the abutments and act as retaining walls. Wing walls retain soil for abutment, roadway, and approach embankment, which can be at right angle to the abutment or splayed at different angles. So the arrangement of this wing wall depend on the various parameters, local conditions. Superstructure, the components of the bridge above the bearing are known as superstructure. In that you will see beams, girders, both have similar function to support the roadway and prevent bending. Girder is also one type of beam support where loads are heavy girders are used in the instead of beam support. So girders have longer span. You can see the flyovers in the cities have longer spans. Pre-tensioning, post-tensioning is also done. Beams have rectangle cross section, whereas girders have composed of eye-shaped cross sections with two load-bearing flanges and wave for stabilization. Here you can see one of the bridge. There are so many columns or piers. You can say these are the piers. This is pier cap on which these girders or beams are rested, and over that you can see the road or deck will be there. Bearings, a bearing is provided between the bridge girder and the pier cap. This is bridge girder. This is pier cap on which this is pier cap on which this particular bearing is rested and it will connect the superstructure. The main function of bearing is to allow free movement of or vibration of this top superstructure and reduce effect stress to reach the bridge foundation. Arches and cables. So you can see such type of arch action. Arch earlier bridges were many bridges constructed on the rivers are also in form of arch supported by the piers in the river course. But this particular arch is used in a broader way, which will support this particular deck from the supports on the land. So there is no any in between pier. So this is longer section like Chenab River section. We will see Chenab River Bridge. So arch and cable both have specified use. Arch are used for arch bridge construction and cables are used for suspension, cable shed bridge, etc. For different types of bridge construction, arches and cable play a vital role. So for different types of bridge construction, arches and cable play a vital role. Parapet wall handrail, this is part of superstructure on the road surface or on the edges of the road. You can see this particular arrangement of parapet wall so that uh, there will be safety for the movement and vehicles will not move from this side below. So parapet is one of the safety component of any bridge which prevent the vehicle from falling off where there is a drop. It is also useful for restricting views and to act as a noise barrier. So this will act as a noise barrier. Even the vision or the drivers will concentrate on the movement of the vehicle in the forward direction, and they will not see on the sides. Flooring can be different as per the requirement. So it is a top surface of bridge roadway on vehicle travel. It is made of concrete or bituminous road. Adjoining structures, it is structures constructed at the starting or ending of the bridge. It is the main function is to provide smooth and easy entry and exit from the bridge. So particularly bridge is the over a river course or valley as a viaduct, but adjoining structures may be some roads connecting that particular bridge or connections and other facilities. Guard stones are the some stones placed on the edges. They are used as restrict traffic on the particular lane or sometimes as a road railing, but are generally positioned to protect a specific object such as corner of the street or side or the gate. Alignment. So alignment depend upon various parameters. Earlier, the alignments were perpendicular to the reverse to reduce forces acting on the piers. But as of now, we can align bridges in different direction in the skew in with angle to the river or valley as per the requirement space available. Because different techniques are available, we can design, simulate the loads acting on the piers, how that particular bridge will behave with different locations, and based on the different studies, we can align the bridge uh, in different locations. So it is the line along which the construction of bridge is carried out. Based on the alignment, there are two type of bridge: skew bridge. This type of bridge alignment of bridge is not perpendicular to the direction of flow of the river, as we discussed, skew bridge. And square bridge, in this type of bridge alignment is perpendicular to the flow of the river. So earlier time, you can see the to cross various rivers, the square bridges were used because there were number of piers in the water. But now, as there are different techniques, advanced techniques used in the construction, there are less piers or columns in the river course, and we can have different types of alignments or different types of bridges like cable stayed bridge uh, or even segmental construction, distress post tensioning bridges. So factors affecting alignment of bridge: highest flood level, we have to see that particular maximum discharge will pass through the bridge. Effect of silting and scoring. We should study the silting and scoring at the foundation level, because after construction of the bridge, there should not be scoring or erosion of the foundation, and there should not be much silting. Means if the silt get deposited, then there will be less space available for the passage of that particular flood discharge. So layout of approach, river training works, there are so many activities to be constructed. You can see in the northern region or northern area in, we can say, Uttar Pradesh or near to Ganga river basin or alignment, or we can say the basin, in that particular basin different bridges are constructed for the passage, and also the river training works are carried out to have limit to the river width, or the flow of that particular channel should be through that particular passage only due to the alluvial soil. So selection of bridge site: an ideal site for bridge across a river should have following characteristics. At bridge site, the reach of the stream should be straight. The site should be geologically sound, should be away from the fault zone, or should have unyielding, not erodible foundations for abutments and piers. At the site, the stream should be narrow with well-defined and firm banks. At site, the river flow should be without wells and cross currents. At the site, there should be suitable high banks above the high flood level on each side. The approaches should be economical. They should not be very high or long or liable to flank attacks of river during the floods. They should be free from obstacles such as hills, frequent drainage crossings, built up areas, sacred areas as graveyards, or troublesome land acquisition, etc. The site should be at reasonable proximity to the direct alignment of the road to be connected. There should be no sharp curves in the approaches. Absence of costly river training works where they are unavoidable, they should be executed in dry as far as possible. Avoidance of excessive underwater construction work. So all these aspects are considered to reduce the cost of construction. Requirement of an ideal bridge site. An ideal bridge must meet the following requirements. It should be economical, it should serve the intended functions with safety and convenience. It should give aesthetic, elegant look. The traffic requirement of highway bridge. Alignment, skew alignment is possible in case to get square crossing with approach. Central verge used to separate traffic flow. Minimum width of 1200 millimeter is to be provided for economic design. So there are different standards we'll see in detail. Footpath, roadway width as per the requirement, side distance, length of bridge, linear waterway of the bridge, width of waterway between the extreme edges of the water surface at HFL measured at right angles to the abutment face. Effective linear waterway, the total width of the waterway of the bridge at HFL minus waterway. So these are the calculation. Discharge is equal to Q is equal to AV. Depending based on that, you can calculate A. Loads and loads combination of the bridge. Dead load. Dead load is the weight of the structure and any permanent load fixed thereon. Live load. On bridges, main load is due to the road traffic and railway trains for designing road bridges. Standard live loads are taken as specifically by Indian Road Congress. So these are the IRC loadings. Longitudinal forces, impact load, thermal forces, wind forces. Wind forces are considered where the wind force is much or bridges are at higher elevation. Force on parapet. So maximum flood discharge. There are various methods to calculate discharge. Empirical methods. Measurement of velocity by Chase's formula, V is equal to C under root RS. Number of spans, economical span of the bridge, score. The term score is used to indicate the increase in the depth in vertical direction of the river beds. So Erosion generally at the river bottom there will be erosion due to flowing water. Clearance or freeboard. A flux, so there is a rise of water on the upstream side. So if water is flowing from this side to there, then there will be little increase in the water depth due to surge. So rise of water level on the upstream side of the bridge is known as a flux. Substructure, so these are the wing walls you can see. So this is box culvert or small, you can say, stream. These are the wing walls. These piers are called as abutment, extreme piers that support alignment. This is the most common type of abutment for a waterway bridge, which is allows smooth entry or exit of the water. Abutment with return wing wall. So you can see different types of wing walls also. If there is no much water flowing, you can have straight wing walls also. Piers. So you must observe different components of different bridges wherever you go. The planning for bridges in cities, in on the highways, or at different elevations is different. Piles, superstructure. Trusses are also used in many places. Railway bridges are many times in form of trusses, steel bridge. Types as culvert, minor bridge, major bridge, long span bridge. When the length of bridge is less than 6 meter, then it is called as culvert. You can see such small culverts on small streams, on smaller roads. And if there are more spans and the width is 8 to 30 meter, then it will be minor span bridge. Major span bridge when the width is 30 to 120 meter. So this will be for larger or bigger rivers. Long span bridge, more than 120 meters, or larger bridges like Bandra Worli Sea Link or various bridges in the ocean. So lift bridges, this particular is vertical lift bridge like Pombon Bridge, newly constructed Pombon Bridge. which supports movement of vessels or the ships from that particular section, and the road alignment is at this level. So this particular alignment obstructs the movement of ships and it is economical. But if we do alignment at this level, then there will be increase in the cost of construction of the bridge, and the use of that particular road or the ships will not be that much. So there is compromise or balance in between the design, and we can let ships when they want to move, as well as the road traffic can be stopped for a particular period of time, and after passage of or movement of that particular ship or vessel, we can continue the movement of road. So basically this is important for the alignment. So you can see the alignment is little closer to the this particular river, or you can see ocean. So this achieves the economy. Sometimes that particular deck or the road section is swing in 90 sorry in 180 degree to have safe passage for the ships. So that is swing bridge. This is cutboard bridge. There are so many types. Some of the types are not used frequently. Transporter bridge, you can see movement of this particular trolley arrangement from one side to another side in the valleys or in the mountains. This particular type of bridge is used. Transverse bridge. Even in Konkan, you can see to cross the different creeks, ships are used. Means from this place, your car will be mounted on the ship and you will be sent to another end to the ship. Arch culverts, box culverts. So depending upon the shape, you can see different type of culverts. Pipe culverts. So pipe culverts are in the circular section. When there is need of more passage, number of pipes are laid horizontally so that more discharge can be passed. Slab culvert, scoopers, causeway, small submerged bridge we can say. So it can get submerged with larger floods, but it can be used when the discharge from that particular river or stream is very low. Okay. If anyone wish to present your topic, Then, okay, so you can watch such number of videos for more in-depth understanding of different concepts, visualization. There are so many informative videos. Now, Utkarsha will present her topic. Utkarsha.
Yes, sir. Take second. Sir, sharing the huh?
Yes, open the presentation.
Yes, sir. This okay.
Minimize the Google Meet and just open the presentation after sharing of the screen.
Yes, sir. Yes, sir.
Yes, be on the presentation.
Yes, sir. Good morning, sir. My topic is Chhatrapati Shivaji Maharaj Terminal, Mumbai Airport, CSMI Terminal Second. Introduction: Chhatrapati Shivaji Maharaj Terminal is the main national terminal of the Mumbai Airport. It is one of the biggest and the most modern airport terminal Indian service both of the domestic and the international passenger. CTAX is the connective major highway and the sure relevant access road, multiple runway with a high aircraft movement and capacity. Location and connectivity. Location located in the Andheri, Mumbai, Maharashtra, connected by the Western Express Highway, shuttle connectivity to railway and the metro station, easily accessible by taxi, auto, and private cars. History inaugurated in the 2014. In 2018, renamed in the honor Chhatrapati Shivaji Maharaj Terminal, replaced the old international terminal. It was the earlier known as the Shahar Airport. Terminal 1 mainly handle domestic flights, and Terminal 2 is a modern terminal opened in 2014. Capacity for the capacity and the operations handle about 55 million passengers per year. Integrate the domestic and the international operation. Advanced air traffic and the baggage handling system operate 24 operates 24 hours a day. One of the biggest airport in India. Architecture and the designing, modern steel and the RCC structure, natural lighting and the Indian cultural event roof design inspired by a peacock. Peacock for focus on the passenger comfort and the smooth flow. Terminal second has a modern iconic design. Passenger facilities, automatic check-in counter, luggages and the waiting areas, restaurants, cafe and duty-free shops. This is the images for the facilities of passenger. Medical and emergency service, free Wi-Fi for passengers, duty shopping and the international terminal. Sustainable features, energy efficiency, lighting system, rainwater harvesting, water management and the recycling, maximum use of daylight, solar panel over to generate the clean energy, LED lighting of save electricity. Importance of a terminal, major gateway of India, financial capacity, boost, boosts tourism and the trade. Example of a modern civil engineering and planning, provide the modern facilities and the comfort and the convenience, enhance the airport capacity and operation. Conclusion: Chhatrapati Shivaji Maharaj Terminal stand as a landmark in India aviation sector, combination and the functionality, sustainability and the architecture excellence. Thank you, sir.
Okay, Utkarsha. Is there anyone else? Okay, who is going to present now?
Can I start, sir?
Yes, tell your name and roll number.
My name is Saili Biswas. Roll number EN 2450 84.
Yes, you can start.
Okay, sir. Good morning, sir. My presentation topic name is movable bridges, but flying lift transport and transport bridge, their requirement and sustainability. The first is movable bridges, types, requirements and sustainability. Introduction. What are the movable bridges? Movable bridges, also known as a draw, drawbridges, are specialized structures designed to open or move to allow a passage of marine traffic such as ships and boats. They are essential where land-based transportation routes like roads or railways intersect with navigable waterways. Why movable bridges? Clearance for vessels, cost-effective solution, strategic placement. General requirements, navigation clearance must provide adequate horizontal and vertical clearance for all expected water traffic. Reliable operation features a smooth, safe, and efficient operational mechanism for opening and closing. Traffic flow minimize distribution to road or rail traffic during operation insurance quick trans- transition. Buskal bridges, the seesaw design mechanism. The Buskal bridge operates by rotating one or two bridges spans upward around a horizontal axis, much like a seesaw. This lifting action is often facilitated by a precisely balanced counterweight system. Requirements and sustainability requires relatively limited horizontal space, making it ideal for congested areas. Swing bridges mechanism. A swing bridge rotates horizontally about a central shear point. Sir,
Okay, stop the sharing screen.
सर मी करू का प्रेझेंटेशन?
Oh,
Sir, my name is Trupti Nare, roll number 38. Good morning, sir. My topic name is Kanpur Military Airport. Introduction. Kanpur Military Airport is officially known as Kanpur Airport, Chakri Air Force Station. It is a dual-use airport servicing both military and civil aviations. The airport plays an important role in India Air Force operations. Kanpur Military Airport. Location. The airport codes location Chakri, Kanpur, Uttar Pradesh, India. Code KNU, ISO, Kanpur region, military of importance, operated by the Indian Air Force RAF. First, base repair, dev, maintenance, and overhaul transport aircraft. Uh, for base repair depot, engine repair, and overall activities supports HAL transport aircraft divisions, civil aviations, and roles. Airport open for civil flights along the military operations. New civil terminal enjoyed in 223 improves air connectivity of Kanpur city infrastructure and facilities. Single operational runway, modern passenger terminals for civil engineering flights, hangars and technical facilities of military aircraft. Strategic importance supports defense logistics and aircraft maintenance, acts as a training and repair hub for the Indian Air Force, enhance regional security and connectivity. Summary. Kanpur Military Airport is a key dual use of airport. It plays a vital role in the national defense, also contributes regional civil aviation development. Thank you, sir.
okay. Is there anyone else? Okay, we will stop then.